Okay, so shall I proceed?
Yes, sir. Thank you.
Yeah. Yeah. Sorry for the initial hiccup. So, uh, yeah, today I would be talking on the spatio-temporal distribution of greenhouse gases, especially the carbon dioxide, methane, and its implication on climate change over the Indian region. So, the how it is the climate change is by two processes actually. One is the impact from the natural sources. The other is anthropogenic causes. So the climatic parameters, which we call as an indicator to the climate change, they are the air temperature, rainfall, rainfall, that is precipitation, and the change in winds, the wind patterns, and also the other aspects of climate, which occurs over the decades, 3 decades, minimum of 3 decades to the centuries. So it is the climate change is, even if it is anthropogenic actions of anthropogenic, which we talk today, that the human influence and industrial activity, even otherwise also the climate change is happening since ages, because that was through natural change. So the always the natural influence of climate change will have a balance on the ecosystem, but whereas the acceleration in the adverse effect of climate change is due to the anthropogenic effect, which has this influence has come. So hardly 60 to 70 years back from the industrial revolution time. So whereas like as I said, the change of solar cycle activity, which happens every 11 years, which changes the radiation, basically how the solar cycle affects on the climate, that is a natural climatic change. But it has a balance, the positive and negative, the effects will be cancelled, and the effect of solar cycle on climate change is zero, because every 11-year cycle, so there will be a change in delta radiation energy that we receive at the earth's surface, but it is balanced in the atmosphere. But because of the industrial activity which has started from 1950s, especially the acceleration has gained momentum during these 1915 era, that has increased so much of greenhouse gases in the atmosphere, and which is causing the disturbance in the radiation budget at the Earth's surface. So the main driving factors for the climate change today in the atmosphere, by the atmospheric species, especially greenhouse gases, that they are CO2, methane, and nitrous oxide N2O, also carbon monoxide, that is secondary greenhouse gases. Whereas the carbon monoxide is known as a pollutant as well as the climate forcing agent, secondary greenhouse gases. And aerosols, like the particles in the atmosphere, the aerosols have two types of aerosols. One is absorbing aerosol, that means it absorbs the radiation, outgoing radiation, which causes heating to the atmosphere. Whereas the scattering aerosol, that sends back the radiation to the space, so that the Earth's atmosphere will be cool. Like for example, the scattering aerosols means the ocean aerosols, the sulfate aerosols we call, they are the cooling aerosols. Whereas the absorbing aerosols, which comes from the biomass burning and the vehicular emissions, due to the combustion, basically the black carbon and all, absorbing aerosol. And also the last 2 decades, the LULC, land use land cover changes, also is having significant impact on the changes of the greenhouse gas emissions. So we are also targeting on the land use land cover changes on the GHG emissions. We are investigating here at NRC. So what are the basically we know that what is the climate change? It is average over 30 years. The phenomena changes in different parameters, climatic parameters, such as the air temperature, precipitation, and the sea level rise, sea surface temperature. So these are all the parameters indicating the whether the climate change is really happening or not. So the adverse effect of climate change has in different spheres of the earth, like increase of greenhouse gas emissions and occurrence of droughts, the increase of drought severity, and also the frequency of drought. Even like you are very well aware about the drought conditions when it comes to the ENSO, El Nino Southern Oscillations. During El Nino time and La Nino time, how these drought condition prevails, because the during El Nino time, sea surface temperature increases. Also it will have an adverse effect to reduce the precipitation at some parts of the globe, so that the occurrence of drought event also happens through because of this ENSO events. So the rise of sea level. So now we are talking about some millimeter level rise is happening every year. So the sea level rise is also the indicator for the climate change. And wildfire, we are every day we are hearing about during the seasons, peak seasons, especially the post monsoon, India post monsoon and the pre monsoon, we see mostly the forest fire activities. So they may be natural as well as anthropogenic, but the forest fire activities are happening. Also wildfires across the globe, that is also happening. And the increase of tropical cyclone activity, that is also increasing ocean acidification, because as we increase the greenhouse gases to the atmosphere, so some of the we should know that how the increase of greenhouse gases in the atmosphere is also absorbed, because there should be a balance in the release of atmosphere CO2. So today, if we are releasing a CO2 to the atmosphere due to the different activities, human activities or industrial activities, that is absorbed by the ocean. So 25% of the CO2 is absorbed by the ocean, and the but because oceans also get saturated at certain point, because of this conversion chemical process, like carbon dioxide will be converted into carbonic acid. So slowly the ocean, it start getting saturated, which will lead to the acidification of the ocean, and that leads to a negative impact on the marine ecosystem. And these are all the adverse effect of climate change, and these are the indicators to see that whether the climate change is really happening or not. And we know that there was a myth a few years back, maybe the 2-3 years back, I can say. So the climate change is really happening or not, because even before, like as I said in my beginning slide, the climate change is also natural process. So even if there is no industrial activity, even if there is no anthropogenic influence, human influence, the climate change was happening and happening now. So but today's momentum in the climate change is from the human, that is anthropogenic influence, because of the many activities, industrial activities, or the change in land use, land cover. So many factors like wildfires, increase of wildfires, they are causing more positive towards the change in climatic parameters, such as the temperature is at the rising phase because of these greenhouse gases. And this team, you all know that this Manabe won the Nobel Prize in 2021 for the global warming concept. He has used a number of models to prove that the global warming is real, and which causing the warming of the Earth's surface, and leading to the rise in temperature. So this phenomena has proved that the climate change is really happening, and it's 100%, and there is no second thought on this, the whether it is changing because of the industrial activity or anthropogenic emission. But the positive adverse effect is due to the industrial activity and anthropogenic sources. So the primary cause for the global warming is, like today we are pumping too much of greenhouse gases, because they are heat trapping gases. As I said, like the incoming radiation and the outgoing long wave radiation should be balanced. But what is happening, because of the presence of these greenhouse gases, in the too much of greenhouse gases in the atmosphere, they are absorbing the outgoing long wave radiation, which is supposed to escape to the space, and that keeps at temperature at the comfortable zone. But what is happening, because of the heat trapping gases, that is CO2 and methane, N2O, they are more in the atmosphere. They are re-radiating back that outgoing long wave radiation to the Earth's surface, causing the increase of temperature to the Earth's surface. So that is how the positive effect is increasing more towards the adverse situation, because of the more pumping of greenhouse gases in the atmosphere. And this is a popular curve, like you must have seen that the Keeling curve, who has started first observations in 1950 at Mauna Loa, that is Hawaii Island in USA. It's a known to be a global pristine site for measuring the carbon dioxide or methane and other greenhouse gases. And at this site, Mauna Loa site, observations from 1950, initially it started with carbon dioxide, because which is a major primary driving forcing of the climate change. Observation started at 1950, and after that the observations of other greenhouse gases such as methane, nitrous oxide, and sulfur hexafluoride, even the ozone depleting substances also measured at this location, Mauna Observatory, to monitor the change in atmospheric greenhouse gases. And also this data is very much useful for the decision making, because this data goes to the model and gives the simulations of atmospheric CO2 for the future, and also to at different regions how the CO2 is varying, because today the variability of CO2 in the Western Ghats and if you go to the Indo-Gangetic plain, the concentrations would be different, because the ecosystem present at the Indo-Gangetic plains and the ecosystem at the Western Ghats are different, and the process at the Western Ghats and the process at Indo-Gangetic plain are different. So these are the controlling factors of atmospheric CO2 and the release of CO2. So these to be understand once we have the long-term data over this region. And we have at NRC ISRO, we have established a ground-based observational network on carbon dioxide, that is CO2 flux towers at different locations of India. This is the map where we are seeing the different measurements of atmospheric CO2 at different locations, covering from north to south and east west. Also the oceanic sites. Sorry. Also, we have installed recently at Lakshadweep Kavareti site to monitor the ocean fluxes. So these are the observational setup installed by the NRC ISRO to monitor the CO2 variability over the India as a function of different ecosystems. Because we have one flux tower at Karnataka, that is to understand the fluxes of CO2 in the forest ecosystem. And one flux tower, CO2 flux tower, we have installed at Kolkata to monitor the urban ecosystem and how the urban, because the main anthropogenic source which comes from the urban. So to understand that, we have also monitoring the CO2 fluxes from the Kolkata and Ooty. Also, we have one site to understand the how this vegetation is influencing for the carbon sequestration. And as part of this program, we are also commissioning 2 more flux towers to at northeastern side of the India and also the Kashmir to understand the glacier ecosystem to the carbon fluxes. And this is I would say this is India's killing curve, because today we have the longest data over the Indian region from the Shadnagar site, which was built by the NRSC ISRO. So from 2013 onwards till today, we are continuously measuring the atmospheric CO2 and methane. If you see here, the data clearly capture the seasonal variability. If the trough and crest, you can see that this period of source and the period of sink. So this kind of data is really helpful to understand the sources of CO2 and sources sinks of CO2. So that what is the net effect of the processes which are controlling the carbon dioxide in the atmosphere. And also methane is, even for the agriculture ecosystem, it is very much important to understand because in the international platform today, the people are talking about India is more contributing more to more of methane to the atmosphere, because which has the methane is having around 25 to 28 times more potential than CO2 when it comes to the warming effect. So that is why it is very important to monitor methane concentration also. And we have initiated, I mean, in the subsequent slides I'll show how the methane is responsible for different sources. And so to understand, because the modeling is very important to for the CO2 and methane, because the observational facility, observational infrastructure, we cannot establish at every location. And once we validate the climate models using the observational data, so these models can be utilized for the upscaling the carbon dioxide, methane in the entire Indian region. So because the carbon dioxide in the atmosphere is not just a local controlled by the local factors, it is even controlled by the transport, because the source is present at a different location. Through transport, air mass transport, the concentration will reach to the some other location. So that we track using the transport models such as the flex part and flex inverse. So those dispersion models also we use to track the sorry, to track the atmospheric CO2 from different locations. And this is one more the state of the art infrastructure we established at NRC ISRO, that is a ground based FTIR spectrometer, that is Fourier transform infrared spectrometer. This is the global network of FTIR, which is very important. That is why if you see the entire globe, many countries are using this FTIR spectrometer for measuring the columnar, entire column from surface to the top of the atmosphere. The greenhouse gases are measured using this FTIR spectrometer. But in the tropical region, there was no observations before 2014. But 2014 we installed FTR spectrometer at NRC Shadnagar campus, which is first of its kind in the country to measure columnar greenhouse gases, especially CO2, CH4, N2O, and carbon monoxide. This is the typical spectrum of the FTIR measurements. So that gives 0.76 micrometer to 2.5 micrometer, which measures CO2, CH4, CO. So I'll not go into details of this, the spectrometer related, but it has a potential to measure the columnar. So far we were talking about only surface level measurements, but whereas this particular instrument is capable to measure these concentrations from surface to the top of the atmosphere, that is roughly 100 kilometer. So these are some of the results, because it gives only spectrum. From this instrument we get the spectrum, but we developed the algorithm that is called line by line ready to transfer algorithm, because this RT model, ready to transfer model, is very much useful in every field, like agriculture field. Also you can use that RT model to simulate the spectra and see that the measured spectra versus the model spectra, how much deviation is there. So if the deviation is too much for the modeled and measured spectra, like you may be measuring the vegetation spectra. So once we simulate with the ready to transfer model spectra, so and we see that the residual is minimum, then we can certify that our measurements are accurate, and the subsequent the research analysis also will lead good result. So using that line by line ready to transfer algorithm, we have retrieved carbon monoxide, methane, carbon dioxide, and this data is also very decisive. That means it's a very reference observations to validate satellite observations. So we have used our the space-based observations from the Sentinel 5P tropomi, retrieved methane and carbon monoxide, and validated against the FTR ground-based FTR measurements, and found good agreement between these measurements. And this is the other aspect of monitoring the greenhouse gases. So we have also conducted airborne campaign in 2016, and also we are going to conduct airborne campaign from this year onwards again to cover different locations of India, especially 6 to 7 locations, and also the specific area we are targeting on northwestern region, because of biomass burning influence and the agriculture residue burning influence and the GHG emissions. So that we are going to address this year with the airborne campaign. And during 2016 profiles, if you see Bhubaneswar, Varanasi, Jodhpur, this India map shows Bhubaneswar, Varanasi, Jodhpur. These three locations we have measured the profiles roughly 4 to 5 days at different layers, the atmospheric CO2, because the majority of the CO2 lies in the surface level, that is below 1 kilometer. But anything beyond 1 kilometer height, that is due to strong convection, or because of the strong convective system, or the transport influence. So to understand and to separate the influence of transport and the convective system, the vertical profiles are very much useful. And also we feed this data, the every height information, the CO2 profile at different altitudes, we feed into the ready to transfer model, and we compute the heating effect of the atmosphere at each altitude, so that we'll be able to understand the atmosphere is getting heated up at what layer of the atmosphere. So that also, so if you see the concentrations mostly in the below 1 kilometer, the maximum high concentrations are below 1 kilometer, and lower concentration is around the 3 kilometer. So the profile is up to 3.2 kilometer we obtained from NRS aircraft. And also, like as Madam Axela Madam said in the introductory remarks, so like we have also continued our observations from Antarctic to Arctic to see that the global level variability of atmospheric CO2, because the Antarctic is known to be a very pristine on the planet Earth. So we wanted to see that the teleconnection between the reference site to the most developed observations, like most developed sites, the contribution of anthropogenic versus there won't be any anthropogenic influence in the Antarctica region. So the background site versus the other observational site. So to understand the how much the concentration of CO2 or methane elevated when we compare with the background site. So we took the Antarctica site as a pristine environment as a background site, and with respect to the background site, we compared in India how much each location, I mean each site of the observational site, how much of this elevated CO2 were observed during this 2015-16 period. And also, like We augmented. We first time we carried out our observations to Arctic also in 2018. We carried out one ultra portable greenhouse gas analyzer. This is a permafrost region. Permafrost region is the permanently frozen ice. It is a mixture of soil and ice beneath the surface. So it stores a lot of carbon in the beneath the surface. So during the thawing process, thawing means during the active summer period, the permafrost starts degrading. So during the degradation process, the whatever the storage in the permafrost, it releases to the atmosphere, and that we wanted to measure. So we carried out these observations in the permafrost region, and we could see that the significant difference between atmospheric methane and the soil methane. There was a huge difference between the soil methane, that means the stored methane in the permafrost, and also the released methane in the atmosphere. So this has given a very interesting challenge to us to conduct the more rigorous experiment in this region, and we are planning in the subsequent years. I'll skip this slide. And this is also like we carried out our observations like southern ocean, like because the oceans are, as I mentioned, oceans are one of the major carbon sequestration on planet Earth, because the CO2 today we release, so 20% goes to the ocean. They absorb ocean through bicarbonic acid form. So to see that which part of the ocean is really acting as a strong sink for CO2. So we could see that, see, these are the two different tracks. We could measure it at different time periods. One is from the South Africa to Bharti station, that is in Antarctica, and the other expedition started from Mauritius to the Bharti. So during these two periods, this is a Mauritius track and this is the South Africa track. So between these two sides, between these two tracks, there is a difference between the carbon dioxide and also methane concentration, because so that is how the ocean marine ecosystem is responding for the CO2. So this still we are though we have collected in 17, we are we are investigating using the model and other approach to bring out the solid analysis from this data. And this is our we have also seen that different latitudes. The y-axis in this figure is a latitude, and this is a x-axis is longitude. So the atmosphere CO2 latitudinally, if you see in the Antarctica, this is the Antarctica region, starting from the South Africa to the Antarctica, and 35 degrees south to 45 degrees south, the concentrations are higher in this zone, in this belt, 35 to 45 latitude belt. But whereas after 45 degrees south to 65 south, the concentrations have dropped. So this indicates, because this belt is close to the mainland, whereas the 45 degrees south to 60 south is far away from and close to the Antarctica. So indicates the pristine environment versus the already well developed environment. So this is indicating the mid latitudes. There is a difference of 6 ppm between these two zones. So that is how it shows that the Antarctica still is not polluted by these greenhouse gases in the atmosphere. And this is where we have carried out methane concentration measurements of methane at different locations over the Arctic region. Even the how the oceans are respiring for this methane and CO2. That also we try to measure. But this, as I said, we are still yet to finalize the outputs from this data. And we are also conducting monthly ozone sonde balloon launching. The ozone sonde balloon launching, this we have done from the College of Horticulture in Telangana here. This balloon launching, which is almost 100 kilometers from airport. This particular project deals with the meteorological parameters at a very high resolution in the vertical high resolution, and it gives a pressure, temperature, wind speed, wind direction, humidity, and also ozone concentration. Ozone in the atmosphere is very much important. Even the troposphere ozone is having a very bad effect on agriculture yield. So you may be carrying out some studies, the impact of troposphere ozone on agriculture crop yield productivity. So that has a very negative impact. The increase of the troposphere ozone in the atmosphere will have a negative impact on agriculture. So maybe because this troposphere ozone product is available, long term data is also available in the NICES portal of our NRSS. say ISRO, one can utilize the data and to see that the impact of troposphere ozone on agriculture yield. So, and we have conducted this. We are conducting this experiment from 4 locations. That is from College of Horticulture and IIST Ponmudi, Kerala, and also RC Nagpur and Jodhpur. 4 locations. These 4 locations are latitudinally separated, equally separated, and because the ozone concentration varies with the latitude, so we have distributed the sites such a way that the latitudinal separation is taken care in the observations. And now, so far we talked about how the ground-based observations are useful for the monitoring of greenhouse gases, and now the from space, because last 2 to 3 decades, remote sensing has become very powerful tool to monitor the space in global scale. So this is the evolution of remote sensing in the field of greenhouse gases from 1996. Though there was a sensor in 1996, but it did not work for a long time. So from the real observations, the actual observations and important useful observations have started from 2002 to till date, and the platforms have on different platforms, different agencies have started measuring these greenhouse gases. European Space Agency, NASA, JAXA, that is Japan. So these are the greenhouse gases, CO2, methane, and other release gases like carbon monoxide, nitrous oxide, even pollution parameters like NO2, ozone, sulfur dioxide. These parameters are measured by the different platform. And today we have, you see the right side, we have the observations have started from 300 kilometer by 300 kilometer resolution. That is a pixel size to 30 meter by 30 meter. So that shows that that is an clear evidence that the remote sensing technology has evolved, and now kilometer resolutions to 30 meters resolution, pixel level information, we are able to see that. So it tells that even we can the sources can be detected at point level. Even the any industry emission can be detected using the satellite data. So today we have even on International Space Station, we have a sensor called EMIT, which can detect the plumes of methane wherever the hotspots of methane are there in the over the globe. It will be able to detect from the EMIT sensor, which is on board of International Space Station. And also this Canadian constellation of GHGSat, greenhouse gas satellite, very high resolution, and it is in a constellation mode in the low Earth orbit. The sensors are placed, and so far the 4 to 6 already the GHG sats are placed for high resolution mapping of CO2 and methane from the space. And so we are also like we are studying this remote sensing data, using remote sensing data, how the atmospheric CO2 over Indian region has changed from 2003 to 2016, even 2022. The concentrations from 375 to 420 ppm it has reached, and it is increasing at the rate of 2 ppm per year. And also when we calculated the anomaly means to see that where is the main sources and sinks are present in the atmosphere of Indian region. So when we saw that, so these Western Ghats and Northeastern regions are showing negative anomaly. That means these 2 branches of Indian region is having a positive effect to sequester the carbon from the atmosphere. So this study also we are progressing. And we have used model data for our ground based, because wherever the background image is a satellite image which is around 2011 period, and the other figure is 2021 year. So within 1 decade of time period, the concentrations have increased from 400 to 420. The 20 ppm concentration has increased. As I said in the previous slide, it is increasing at the rate of 2 ppm per year. And these are the locations of our ground based observations, to also to validate against the satellite observations, and also to use to complement with the existing the satellite observations and ground based observations, to monitor the seasonal and diurnal variations of these green CO2 concentration in the atmosphere. And these observations are very much useful because we validated against the model. So the model can be used for further upscaling of the greenhouse gases using the climate models and transport model. And also we have because now AML has become very popular, and also very useful tool for the simulation of different parameters, and also for the forecasting of different parameters. So we have started using simulated using our observations data, 10 years of observations data at Shadnagar, and we could be able to pick up the seasonal variability of CO2 using AML technique. And this is one thing I mean, very interesting thing. Just I want to tell you that the identification of potential leaks of methane. Sorry. We have two kinds of platform. That is a GOSAT, which was existing from the JAXA, and the recently European Space Agency in 2018. The data has been made operational from 2018, whereas the GOSAT is from 2008, whereas the Sentinel 5P, that is a European Space Agency, from 2018. So within a decadal time period, the resolution from GOSAT is a 10 kilometer to now it is the TROPOMI, which is European Space Agency, has come to 5.5 kilometer to 3.5 kilometer resolution. That means, so we were at some time back, we were at a regional level detection of methane leaks, but today we have at a point level detection of methane. These are all high concentration zones of methane, the strong emissions of methane over the Indian region, especially if you see the Indo-Gangetic Plain region and also some part of northeastern region is emitting more methane. To clearly understand, we have applied the statistical methods in this the emission data, methane emissions, to highlight the significant zones of methane leaks, methane emission zones. So when we applied the statistical technique on this data, we could see that the Indo-Gangetic Plain region, this entire plains region, and also the some part of northeast is exhibiting more emissions, because the reason could be like we have because satellite gives a concentration. The emissions is a top-down bottom-up approach method. So the emission inventory data. So when we correlated concentrations versus the emissions, it is highly correlated in the Indo-Gangetic Plain region. The reasons we'll talk in the subsequent slides. Sorry. This is 2009 to 2022. You see that the evolution of methane concentration. It started from 2019, 1700 ppb. That's a parts per billion volume. The units, like just to give you the details about the units. If you consider in the atmosphere 1 million molecules of air in the atmosphere, here 1700 molecules of methane in that 1 million molecules of air. So that is the indication of this unit ppb, parts per billion volume. So from 1700 ppb to 1950 ppb. So it has increased almost to 250 ppb concentration in the last 1 decade, more than 1 decade observation. So like in the beginning of the slide when we discussed this 250 ppb, when we give it to the ready to transfer modeling, this will have a huge positive warming effect when we compared to the CO2. Even compared to the CO2, it will have more warming effect in the atmosphere. And like the entire region, to see that the total hotspot zones of methane, the tropical belt is more generation of methane in the atmosphere. So a previous slide, on this also we have applied the statistical methods to highlight the prominent zones of methane concentration, and it shows that the tropical zones of the entire globe is contributing more methane to the atmosphere. And using this Sentinel European Space Agency, we could able to even detect the point level that as we discussed in just before this slide. So we are able to see that the concentration of methane in the coalfield, Sundarbans, and also the coalfield. We have selected 2 coalfields here, 1 and 2, and this is the Sundarban area, which is a wetland. So you know that the emissions varies from source to source. Thermal power plants, and also the wetlands, and also the agriculture. These are all major sources of methane in the atmosphere. And also the reduction of methane from the atmosphere is by the chemical photochemical reaction, that is hydroxyl radical, OH radical. It dissociates the methane molecule, and that is how the methane is removed from the atmosphere. And here I just want to highlight the coalfield versus Sundarban. This is the natural source of methane, Sundarbans. That is the largest wetland in the Indian region. And the coal field is the anthropogenic source, that is a humans anthropogenic source, and this is a natural source. And the natural source versus anthropogenic source, if you see the concentrations here, the blue color indicates around 1880 to 80 ppb to 1890 ppb, but whereas in the coal field the concentrations are around 1950 ppb. So it indicates, it's a clear indication that the anthropogenic effect is more dominant than over natural the ecosystem natural sources. And this is all like yearly the changes of the high resolution methane mapping. So like previously we have seen the coarse resolution, moderate resolution, I would say, so 10 kilometer now, but now we are able to see that 5.5 kilometer resolution, so even point level source can be detected. And this is like one of the interesting, even very useful for your future studies, the CH4 emission, methane emissions over the in India's agroclimatic zone. You all know that the 15 climatic zones are there over India. 15 agroclimatic zones based on their again climatic patterns. These 15 zones are divided. You are very well aware about how the agroclimatic zones are divided in the country. So in that, so we have seen the emissions of methane over each agroclimatic zone, and we found that, so some of the, like out of 15 zones, so only this Indo-Gangetic plain zones, like there are the upper Gangetic plains, trans Gangetic plains, lower Gangetic plains, and even the eastern hills. So in the eastern zones, so these are all 6 zones. The out of all 15 zones, 6 agroclimatic zones are highly contributing to the methane. So this also is an study that we have taken up to see that how much the agriculture, the agroclimatic zones where the active agriculture is happening, especially in these zones, you have mainly the rice and wheat. These are the two dominant the practices of agriculture in these Indo-Gangetic plain zones. And also in this region, the population density is very high. I mean, I can say that it is one of the area the large population density is in this Indo-Gangetic plain region. Also, in the industrial activities also prominent over this region. So altogether, like agroclimatic zones, the effect from the agriculture practices in this region, and also industrial activity and the population density altogether, it is more contributing over the 6 zones of 15 agroclimatic zones. So like you can see here, the fossil fuel production and fuel it considers only 19%, but agriculture and waste, it is together the 38% contribution, and biomass burning 5%, wetlands 31%. So we have a detailed, we have taken up a studies to see that how the coal thermal power plants and wetlands and agroclimatic zones are contributing to the methane emissions in the Indian region. And this is one very interesting thing. Interesting thing we have demonstrated. This is a hyperspectral imaging sensor. Hyperspectral is nothing but the continuous bands. Basically, it is with a high resolution spectral resolution. Between two bands, the resolution is very narrow. So very high resolution data we obtained from the as part of ISRO NASA collaboration. We have on board of our NRS aircraft, we have flown this EVRIS NG, that is airborne visible infrared imaging spectrometer. NG means next generation. So it has 224 spectral bands. So it has a variety of applications: agriculture, minerals, atmospheric composition, water, cryosphere, many applications, because it is a beautiful data which is having 224 bands, spectral bands, and every spectral band will have its unique information. So in which we have used our shortwave infrared region to detect the methane mapping, methane concentration over the paddy fields. So these are all this is the radiance image. This is a basic image that we obtained from the sensor, that is EVRIS NG. So we have again applied the ready to transfer algorithm to estimate the methane concentration. So these are all yellow spots over the paddy fields. These are all agriculture fields. The high concentrations are the emissions from the paddy field. So and these concentrations are validated using the ground-based remote sensing instrument, that is FTIR, which we have at Shadnagar. So we have validated this the output from the EVRIS NG, and it shows that EVRIS NG has a potential to detect the methane from the agriculture, even the point level source from the using that EVRIS NG data. And this is the upcoming mission that we are going to do we started, we very recently started in the last year. So we are going to do different campaigns to understand the land atmosphere interactions of GHGs, aids interactions of GHGs, and transport pathways. So the source is somewhere, source is located somewhere, and how it is transported to the some other location and elevating the concentration at that particular location. So we are going to address all these things by doing these campaigns, land, ocean, and airborne. So airborne, we are going to start very soon using our equipments. We'll be installing all our GHG equipments in this aircraft, and we'll be flying for measuring the different vertical profiles of atmospheric CO2, CH4, N2, and pollution parameters. And also we are participating in the ocean campaign to study that aids interaction and also marine transport influence on the CO2 concentration in the atmosphere. And we are expecting that identification of sourcings of CO2 and feedback mechanism for different climatic zones for the CO2. So India has different climatic zones in which we are targeting 9 to 10 climatic zones, and each climatic zone, how it is, I mean, the feedback of each climatic zone atmospheric CO2, and estimating the carbon budgeting using the model and the remote sensing data. And also this is actually the climatic zone. Again, we are going to use the land use land cover also to see that the emissions with respect to the land use land cover changes. So this ultimately will give us the carbon budgeting over the Indian region, which are the region contributing to the more source, and which are the regions acting as a sink for the CO2 for the Indian region, so that the that budgeting information will be useful for the policy decision makers to take the decision and to plan the mitigation strategies.